We're working with two quantities and exponents here. So before we get started, we should remember some exponent rules. For example, n to the third raised to the fifth power. We have to remember what the rule is when we're working with a power to a power. And when you raise an exponent or a power to another exponent or power, we multiply. So in multiplying those exponents, we would get 3 times 5, or n to the 15th. N to the 15th is still being multiplied by n squared. So when we have like bases, we need to add the exponents. So in this case, n to the second times n to the 15th would give us n to the 17th power. Now, using these same two rules on quantity B, we'll start with n to the fifth raised to the second power, which is n to the 10th. That is still being multiplied by n to the third. So when we multiply like bases, we add those exponents, giving us n to the 13th. Now, it might look like n to the 17th is larger than n to the 13th. So we might automatically assume that quantity A is larger. However, that would be plugging in a positive number. For example, 2 to the 17th is greater than 2 to the 13th. However, we always have to remember that we can plug in negative numbers. We could plug in 1, for example. 1 to the 17th equals 1 to the 13th. That automatically gives us two different answers. Also, we could plug in negative numbers. Negative 2 to the 17th is actually going to be less than negative 2 to the 13th. So with all these different answers, what we have to come up with is that we cannot determine the relationship based on the given information.